Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
Today, we are opening up a topic that sounds like a technical glitch, but is actually a financial black hole for some of the world's biggest industries.
Yeah.
And I'm not talking about supply chains breaking down across the ocean or, ships getting stuck in canals. I'm talking about a breakdown happening inside the same building.
Sometimes between two people sitting right next to each other. It's
Yeah.
wild when you dig into it.
Exactly. It's this silent war between the people who dream up the products, the designers, and then the people who have to figure out how to physically build them, the manufacturers.
Mm-hmm.
We've combed through a stack of, technical white papers, integration guides from folks like CAD Talk and OpenBOM, plus some pretty alarming industry reports from aerospace all the way to fashion.
And the mission today is to figure out why these two groups, who are supposed to be on the same team, wearing the same jersey, are often operating in completely different realities.
Right.
We're going to look at why this version confusion is costing billions, investigate a really terrifying concept called the rule of 10, and see if there's actually a way to fix this data disconnect.
So let's start with the scene of the crime. Because in my head, I picture the seamless handoff. The design team finishes the plans, they high-five, maybe grab a coffee.
Yeah, that's the dream.
And they just send it downstairs to the factory. But the sources we read paint a very, very different picture.
A much more stressful picture. Imagine this scenario, which it came up in a few of the case studies. You have the design team upstairs. They are popping champagne because they just finalized version 2.0 of a new high-tech widget.
Okay.
It's sleek. It passed the simulation. It is perfect.
Done and dusted. Time to celebrate.
Ideally. But downstairs on the factory floor, the production manager is, literally panic sweating.
Why?
Because the blueprints on his tablet don't match the pile of steel parts that just arrived on the loading dock. He's looking at version 2.0 on his screen, but the procurement system, it ordered parts for version 1.5.
Ah, that is the digital chasm.
That is it right there. And it happens because structurally, design and manufacturing are not just different departments. They are, for all intents and purposes, different species living in completely different ecosystems.
Okay, let's unpack that ecosystem idea, because the sources use this phrase, a tale of two realities. It sounds dramatic, but what are these two realities?
So on one side, you have the design factory. This is the world of the engineers and the creative. Their habitat is the KLM product lifecycle management, or the CAD system.
Computer-aided design.
Yep.
Okay, so this is the sandbox. It's creative. It's flexible. This is where the magic happens.
Exactly. Their currency is innovation. They live in a world that is iterative. They might change the curve of a fender or the stitching on a pocket 20 times in a single afternoon. To them, the product it's fluid.
It's always in an as-designed state.
As designed, right. It's hypothetical until they say stop.
Okay. And then you have the folks downstairs.
Right. The production factory. Their habitat is the ERP enterprise resource planning. This is the system that runs the business. It buys the metal, pays the workers, tracks the shipping.
It handles the invoices.
It handles everything. Their currency isn't innovation, it's discipline.
Because you can't iterate on a factory line while it's moving.
You absolutely cannot. Once you order 10 tons of steel, you can't just tweak the curve because you had a better idea in the shower. They live in the as-built world.
Right.
They care about inventory, cost, and hard releases. So you have one group saying, let's keep improving it, and the other group screaming, stop touching it, we need to build it.
And that friction isn't just, annoying. It creates massive data confusion. There was one statistic in the research from an aerospace manufacturer that really blew my mind. It was about a wing component.
Oh, the 47 versions. This is a perfect example of the disconnect. So the design team, working in their CAD system, had iterated this specific wing part 47 times. Version 47 was the final, approved, safe version.
Okay, 47 iterations. That sounds like thorough engineering.
It is. But the ERP system, the system responsible for actually buying the materials and telling the floor what to assemble, it only knew about 12 of them.
Only 12?
It had stopped listening, essentially, or the updates weren't transferring correctly.
So the factory is building version 12, thinking it's the final product, while the designers are upstairs celebrating version 47.
Precisely. And in aerospace, you can't just, make it work with a hammer. The parts didn't fit, And even if they did, they weren't compliant with the new safety specs.
And the result?
The result was $800,000 in compliance violations, scrap metal, and delayed deliveries.
Nearly $1 million just because the two software systems weren't speaking the same language.
And that brings us to the core technical problem here. It's not just that they didn't email each other, it's the BOM disconnect.
The bill of materials.
Right, the list of ingredients. The sources really emphasize that there isn't just one bill of materials. There is the EBOM, the engineering bill of materials, and the MBOM, the manufacturing bill of materials.
I think for a lot of people, and I mean definitely for me before I read this, the assumption is that those are the same list. You know, if the engineer puts a screw in the design.
The manufacturer puts a screw in the product.
Yeah, copy-paste. Why is that hard?
If only it were that simple. The sources call them different animals. Think of the EBOM as a kind of functional map. The engineer says, to make this stand up, we need 4 screws, 2 brackets, and a base. It's organized by geometry or system. It's basically a drawing.
Okay, that makes sense.
But the M by M is a strategy. The factory manager looks at that list and asks completely different questions. Do those screws come in a pre-sorted kit, or do we buy them individually? Do we make that bracket in-house, or do we buy it from a vendor?
Oh, right. Do we need glue to hold the screw in while we tighten it?
Exactly. So the EBOM is, here's the stuff, and the MBOM is, here's how we actually assemble the stuff in the real world. It includes packaging, grease, paint, labor steps.
So if you just dump an EBOM into an ERP system...
The factory literally cannot build the product. It's what the sources call a need for intelligent translation. Without it, they have the ingredients, but no recipe, no pots, and no pans.
And that translation process, getting from the ABOM to the MBOM, is where the errors creep in, which leads us to the rule of 10. This was from that ITI white paper, and this felt like the scariest part of the reading to me. It just shows how fast money burns.
It is terrifying because it's a multiplier. It explains why catching these data disconnects early is, well, it's life or death for a company's profit margin.
Okay, walk us through the math on this.
Okay, so let's say you find a data error, like a wrong part number, while the product is still in the design phase. It's just on the computer screen.
It's virtual.
Right. The cost to fix it is basically $1. 1 unit of effort. You hit backspace, you rewrite the number.
Negligible. A sip of coffee costs more.
Exactly. Now, let's say that error escapes. It creates what they call an engineering escape. It gets into the production planning phase. Maybe you've ordered some tooling or set up the line.
Okay.
The cost to fix it now jumps to $1,000.
It's 1,000 times more. Already a big jump. That catches your attention.
But here is the nightmare scenario. If that error hits full production, if the factory is running, metal is being cut, and products are being boxed, the cost to fix that same error is 20,000 times the original cost.
20,000 times? That is insane.
It is, because now you aren't just changing a file, you are scrapping physical inventory. You are halting an assembly line that might cost $10,000 an hour just to keep the lights on and the workers paid.
You're paying overtime for rework. You might be recalling products from customers.
All of it.
And there was a specific case study about this in the automotive sector, a brake component.
Yes, This is a classic escape story. The engineers realized a brake part needed a tighter tolerance to be safe. So they updated the CAD model. Let's call it version 5.
Good engineering work. Safety first. Problem solved.
In the design room, yes. But the ERP system didn't get the memo. It kept ordering raw materials for the version 4 tolerance.
Oh, no.
They ran the production. Thousands of parts. And none of them passed quality control.
So there are just useless hunks of metal sitting in a bin.
Useless. That single disconnect, one system not telling the other about a tiny number change, cost them $2.3 million annually in scrap and damaged relationships with their OEM customers.
Wow, and it creates this phenomenon the sources call phantom inventory, which sounds like a ghost story, but I assume it's an accounting nightmare.
It is. It means your system says you have 500 units of Part A, but when you go to the shelf, you actually have 500 units of Part A revised. Or worse, the system says the bin is full, but the design team deprecated that part 3 weeks ago, so you actually have a bin full of trash.
You're storing waste. You're heating a warehouse to store garbage.
You are paying to store waste, and you're counting it as an asset on your balance sheet until you realize it's worthless.
Now, I know what you might be thinking. Okay, this makes sense for building airplanes or cars, you know, complex stuff with thousands of parts.
Right.
But surely simple industries don't have this problem. But we looked at the fashion and furniture industries, and honestly, it look even worse?
It's arguably worse because it is so manual. In aerospace, at least they have the sophisticated software. In fashion, the source of truth is often a PDF.
Or an Excel spreadsheet.
Yeah, that gets emailed back and forth. The tech pack.
The tech pack.
This is the Bible for the factory. It tells them how to make the shirt. But the sources highlight what they call the guesswork factor.
Which is not a phrase you want to hear associated with manufacturing. You want precision, not guessing.
No. But if a designer sends a tech pack that says make it medium size, but doesn't specify the exact tolerance like plus or minus half a centimeter, or doesn't specify the exact stitch type, the factory doesn't stop and ask.
They just guess.
They have quotas to hit, they guess. They use the stitch from the last job. Or they interpret the color blue differently than the designer intended. Or they see a blurry sketch of a pocket and just improvise.
And then they ship the sample all the way across the ocean?
The designer opens the box, screams because it looks wrong, and sends it back with notes. The sources say it typically takes 3 to 5 rounds of physical samples to get a single garment right.
That's months.
Months of time and huge amounts of shipping fuel, purely because the data wasn't clear. It's the same story as the aerospace wing, just with fabric instead of aluminum.
The idea in the head isn't translating to the hand.
Exactly.
So let's pivot to the solution. We know the problem is expensive. We know it's universal. Why are we still doing this? I saw a stat that said engineers spend huge chunks of their week just doing manual data entry.
That's the manual trap. One source suggested doing a time audit. If you track a highly paid engineer for a week, you will likely find they spend 20 to 30% of their time just exporting a beam from SolidWorks, opening the ERP window on a second monitor.
And just typing in part numbers.
Just typing. That is a soul-crushing waste of talent. You pay these people to invent, not to type.
And it's dangerous.
It's boring, it's expensive, and worst of all, it's dangerous. Manual data entry has an error rate of about 2 to 5%.
That sounds low, though. 95% accuracy sounds like an A grade in school.
It sounds low until you do the math on a complex product. If a machine has 1,000 parts and you have a 5% error rate, you are guaranteeing 50 errors in every single build.
Wow.
That is 50 opportunities for the rule of 10 to kick in, 50 chances to lose millions.
So the solution isn't type faster or be more careful, it's integration. But the sources were specific, not just connecting the systems, but using middleware.
Right. You can't just hotwire the two systems together because, remember, they speak different languages. Geometry versus inventory. You need a translator.
Like the platforms we mentioned earlier, CAD Talk or iHub.
Correct. These act as the middleware. They take the E-bomb, they apply a set of rules logic like, if this is a bolt, check if we have it in stock, and attach the standard nut. And then they write the emblem into the ERP automatically.
So no human typing.
Zero typing. But the real game changer the sources point out is bidirectional flow.
Meaning the data goes both ways. Why is that so important? I get why the factory needs the design data, but why does the designer need the factory data?
Think about that engineer designing a circuit board. Usually they design the whole thing, send it to the factory, and the factory says, hey, this microchip you used, it's obsolete, we can't buy it anymore.
And then they have to redesign the whole board from scratch.
Nightmare. With bidirectional integration, the engineer's working in their design tool, they pick that chip, and a little red flag pops up instantly saying, warning, end of life, zero inventory, high cost.
Wow. So they see the supply chain reality while they are designing.
Exactly. They swap the chip right then and there. That swap costs $1. They just avoided the $20,000 problem down the line. It turns the designer into a more business-savvy partner without them even trying.
That seems like such an obvious win. It saves money, it saves time, it saves sanity. So here is the big question. Why isn't everyone doing this? The research mentioned that 81% of executives still say poor integration is their biggest headache. Why haven't they fixed it?
This is where we leave the technical world and enter the psychological one. The barriers aren't software anymore. They're culture.
The soft barriers.
The sources talk about information hoarding. It's a very human instinct. In many corporate cultures, holding on to your data is a way to maintain power. If I'm the only one who understands the spreadsheet,
I'm indispensable.
I'm indispensable. You can't fire me because I'm the only one who knows where the numbers are.
Job security through obscurity.
Exactly. But there is also a more sympathetic reason. Fear. Vulnerability. If the manufacturing team can see your design data in real time via that bidirectional link, they can see your mistakes in real time. They can see you struggling with a tolerance. They can see the ugly draft.
And engineers are perfectionists. They don't want to show their work until it receives an A+ again.
Right, so they keep the data in their silo until it is perfect. But by the time it's perfect and they finally release it, it's too late for manufacturing to give feedback on cost or sourcing.
So the silo makes them feel safe, but it hurts the company.
It creates the silo problem, and this is becoming absolutely critical right now because of the buzzword of the century, AI.
I was waiting for this. Everyone wants the smart factory, the agentic AI that runs itself.
Everyone wants the robot to run the factory, but the sources are brutally clear on this. AI needs a clean thread of data.
Garbage in, garbage out.
But at the speed of light. If you feed an AI conflicting data, like the 47 versions versus 12 versions, the AI won't just make a mistake. It will hallucinate a solution based on bad math and execute it instantly.
So if you want the sci-fi future, you have to fix the boring spreadsheet problems of the present first.
You need what they call absorptive capacity. Your organization has to be able to digest the data. If your culture is built on hiding mistakes and hoarding files, buying the most expensive AI integration software won't save you. You need data literacy from the shop floor to the top floor.
It requires a mindset shift, treating the recipe and the meal as one continuous thing.
One single source of truth.
So let's wrap this up for you. We've covered the digital chasm, the exploding costs of the rule of 10, and the psychological barriers to sharing. What's the bottom line here?
The bottom line is that the divide between design and manufacturing is not just a technical annoyance. It is a financial hemorrhage. It drains money through scrapped parts, wasted engineering hours, and missed market opportunities.
And the fix isn't just better software, it's transparency.
It's tearing down the wall. When the designer updates a file, the manufacturer knows. When the manufacturer marks a part as out of stock, the designer knows. Instant alignment.
It sounds simple, but as we've seen, it's rare. And I want to leave you with a thought that came up in the research. The technology to fix this, middleware, API integration, it's been around since at least 2006.
It is not new tech. It's been sitting on the shelf for a long time.
So, if the tools exist and the cost of not using them is in the millions, why do so many companies still choose to run two separate versions of reality?
That is the uncomfortable question.
Is it possible that some departments actually prefer the chaos? Because chaos provides cover. If the data is messy, it's hard to pinpoint exactly who made the mistake.
Accountability is scary. If you fix the data, you remove the excuses. You remove the ability to blame the other guys downstairs.
Something to mull over. If your organization has data silos, ask yourself, are they there because of technical limitations? Or are they there because they make people feel safe?
And if it's the latter, you don't have a software problem. You have a culture problem.
We'll leave you with that. Thanks for taking the deep dive with us today. Check your silos, and we'll see you on the next one.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Looking for more knowledge and inspiration? Head over to our website. You'll find everything you need to keep building smarter.